Qubit, I keep thinking about what you said. The whole sky is running away from us.
I did leave you on quite the cliff, didn't I?
Every galaxy out there is drifting off. Is it something we said?
No. And that exact worry is the one I want to melt today.
So we're not being abandoned by the entire universe.
Not abandoned. You're watching the most astonishing thing the universe does.
Which is,
Growing. The space between the galaxies is quietly getting bigger, everywhere, all the time.
the space is getting bigger, not the galaxies moving?
That's the whole secret, and it's stranger than anything flying through space.
How can empty space just make more of itself?
It's the biggest idea we've ever chased, and it rewrites where everything began.
Okay, melt my worry and blow my mind while you're at it.
Gladly, let's watch the universe grow.
Vega and Qubit, and the sky that's running away.
First, throw out the idea that the galaxies are zooming away like rockets.
But they are getting farther apart.
They are, but the galaxies mostly sit still while the space between them swells.
Give me a picture I can actually hold on to.
Picture raisins in a loaf of dough as it bakes and rises. Every raisin drifts away from every other one, not by swimming, but because the dough grows.
So the raisins aren't moving. The dough is doing all the work.
Exactly, and out there, space itself is the dough.
The universe is a loaf that never stops rising.
A loaf with no crust and no edge, just endless dough swelling everywhere.
No edge at all?
None we can point to. Hold that thought, it matters later.
Filing it away. So what does all this rising actually look like from here?
Here's the first clue we can measure. The farther a galaxy, the faster it drifts.
Farther ones move away faster. Why would distance change the speed?
Because more space sits between you and a distant galaxy, more dough to stretch.
More space in between means more stretching adds up.
Double the distance, and it drifts away twice as fast.
So the whole sky drifts, but the distant parts race.
About a century ago, astronomers first spotted that very pattern.
They actually caught the universe growing?
They caught the fingerprint of it, written into the color of the light.
The color of the light. Now you have to explain that.
When space stretches, it stretches everything crossing it, including the light itself.
The light wave gets physically stretched out?
Longer and longer, and longer light waves look redder to our eyes.
So faraway galaxies look redder than they really are.
We call it redshift, and the farther the galaxy, the redder its light arrives.
So the redness is basically a speedometer for the whole universe.
Now you're really thinking like a scientist. Redder light means more space did the stretching, a farther, older galaxy.
And this is something you can actually measure, not just guess?
Measured for thousands of galaxies, the pattern holds every time.
The universe told on itself, in red.
It did, and following that red trail leads somewhere astonishing.
Okay, but last time you swore nothing can outrun light.
And I meant it. Nothing can move through space faster than light.
But you also said galaxies get carried away faster than light.
They do, and both are true because those are two completely different things.
Different how?
Nothing is racing through space. The space in between is simply making more of itself. Pile up enough stretching space, and the gap can grow faster than light can cross it.
So the galaxy isn't speeding, the space is just piling up between us.
The galaxy could be sitting perfectly still and still be swept beyond light's reach.
That's the sneakiest loophole in the universe.
Light's limit governs racing through space. It never promised to limit space itself.
So last time's rule isn't broken, it just doesn't apply to the dough.
Perfectly put. The rule stands, and the universe still outgrows it.
So what happens to the light from a galaxy that far?
If the space between us grows faster than its light can cross, that light never arrives.
Never, not even if we wait forever?
Never. So there's a bubble around us of everything we could ever see.
An edge to what we can see, but not an edge to the universe itself.
Exactly. The universe runs on well past it. We just can't get the mail from out there.
So some galaxies are sending us light that will never, ever land.
Some are already slipping past that horizon as we speak.
That's beautiful and a little heartbreaking.
Now back to the worry I promised to melt.
Right? Is everything running from US, like we're the center?
Here's the wonderful twist. Everyone, everywhere, sees the same thing.
Every galaxy thinks the sky is running from them?
Picture dots drawn on a balloon as you blow it up. Every dot watches all the others slide away, and not one of them is the center.
Because the surface is growing everywhere at once.
So we're not special or left behind. We're riding the growth like everyone else.
Okay, that genuinely melts the worry. But wait, what is the balloon expanding into?
The balloon's a picture with one flaw. The real thing isn't expanding into anything.
There's no outside for it to grow into?
No outside, no empty room waiting. The space itself is simply becoming more space.
My brain just did a little somersault.
And here's the honest fine print so you don't lose more sleep.
Uh-oh, is space stretching me right now?
Not one bit. You, the Earth, the Sun, and our whole galaxy are all held firmly together.
So the stretching doesn't win everywhere?
Only in the vast, near-empty gulfs between galaxy groups where gravity's too weak to hold on.
Gravity keeps the neighborhoods together while the empty highways grow.
Beautifully said. Your atoms are safe, your planet is safe, your galaxy is safe.
So it's only the biggest, emptiest scales that feel the growth.
The universe grows in the gaps too big for gravity to bridge.
Okay, so if the gaps are growing now,
You're about to ask the best question of all, so let's run the loaf backward.
if everything's spreading apart now, then long ago it was all closer together.
Closer and hotter, rewind far enough, and everything was crushed, unimaginably dense and blazing.
Squeezed down to almost nothing.
A hot, dense beginning happening everywhere at once. The Big Bang, about 13.8 billion years ago.
So expansion isn't just happening, it's the leftover of how everything began.
And remember the oldest, faintest light from our very first trip.
The 13-billion-year-old light?
The very oldest of it is the Big Bang's own afterglow, still arriving from every direction.
The universe's baby picture is still in the mail?
Stretched so far by all that growth that it's cooled to a whisper, but it's really there.
So every time we look far, we're looking back toward the beginning.
The farthest light is the oldest news there is. The story of the start, written in red.
The running away sky was a birth certificate the whole time.
Let's climb the distance ladder, farther, faster, redder every rung. A nearby galaxy, a gentle drift, a faint blush of red. A far-off cluster, quicker away and noticeably redder. A distant, ancient galaxy, racing away, its light deeply reddened. Past a certain rung, carried off faster than light, slipping beyond our reach. And at the very top, the first light of all, stretched clear across the sky.
One ladder from the next galaxy over all the way back to the beginning.
Every rung the same story, growing space, reddening light.
So the sky isn't running from us, it's just growing, everywhere, all at once.
Everywhere, yes. Forever is the question that keeps me up.
Wait, will all this stretching ever slow down and stop?
You'd expect gravity to hit the brakes, but it's doing the exact opposite.
The opposite. It's speeding up?
Next time, a mysterious push filling all of space, driving the universe apart faster and faster.
A push nobody can even see?
The biggest mystery in the universe, and it has a name we'll unwrap together.
If your mind is officially blown, same. Subscribe so you're here when we name the mystery.
Riding the rising loaf all the way home.
See you out there, explorers.